Hello everybody, my name is Art. I'm the founder of Practical Programming, a coding bootcamp here in New York. Also, I wrote a couple of Python books, how to use Python for web development and how to use Python for data analysis, finance, and marketing. You could check them out. You'll find the links in the description to this video. And today we're going to be doing Intro to Pandas. Pandas is really powerful and really popular library for data analysis, all right? So my goal today is to explain you the main things about Pandas and show you how you could get started with Pandas and explain your main built-in data structures in Pandas. So we're going to be doing a lot of coding. And if you want to code along with me, I'm going to be using Jupyter Anaconda. If you have no idea what I'm talking about, please check one of my previous videos. I explained everything, how to get started with Python, and I showed a couple of Python environments. Now, if you do not have time for that, you could also run the same code as I'm going to be writing in Google Colab. Google Colab is like really powerful tool, and you can find the link right in the description to this video, like down there. Please check. Also, this session is for complete beginners, so we're gonna start from scratch. And even if you're just making your first steps in Python programming, that's going to be totally fine. So that's the whole idea to get started today. Now, at the end of the session, we will have Q&A session. And if you have questions, please do not hesitate and just post them in our chat. I'm going to keep an eye on our chat. So also, I'd appreciate if you could tell me if you could hear me fine, if my mic working is fine. And we're going to get started. All right. Let me switch to my computer screen. All right, so this is Jupyter. All right, so I hope you got one. If you do not have one, so this is Google Colab. Again, for Google Colab, you don't need to install anything, and it will take just a couple of minutes to get registered with them. And you'll find the link right in the description to this video. All right, so let's get started. And I'm going to be writing code here and here at the beginning, and then you'll choose whichever you wanna. I'm gonna stick to Jupyter actually, all right? But I'm gonna show you how to use Colab if you've never used it before. All right. So first thing first, I'm gonna import pandas, and then I'm gonna explain you everything about pandas. All right. But I'm gonna show you the first command: import pandas as PD. All right. Oops, pandas. I'm misspelling all the time. And here, and again, like my point right now, I just want to show you how to use Colab if you never used it before. So here you also do import pandas as PD, and you need to run the cell, so please click this play button. All right. All right, so I hope this stuff works for you. All right, now let's start with pandas. So first thing first, why pandas? What, are we going to be talking about these cute little bears that out there somewhere in China? No, 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 no. Pandas actually stands for panel data. Panel data is a econometric term, and also I guess they use the same term in statistics, but I'm not sure. What it means two-dimensional object with two dimensions. All right, so it's pretty much how you could analyze data. In a nutshell, it kind of looks like a spreadsheet with columns and rows. So that's what panel data is. All right, so panel data was I'm not going to lie to you, I don't remember. I think it was 2013, maybe. You could Google it. But the point I'm trying to make, it was developed because although Python is cool, but people in finance, especially on Wall Street, they need to move faster, right? So markets fast, so you gotta make like fast decisions, you gotta analyze tons of data data sometimes in real time. So you want to go faster than just like regular Python. So one guy, and I believe he worked at some hedge funds, so he started working on a new library. And the core for that library was Numpy. All right, so Numpy is another very powerful library for data analysis. It stands for numeric Python. You probably heard about it, like really, really powerful. So what he decided to do, he borrowed some stuff from Numpy, such as Numpy array, and built some stuff on top of that Numpy array to build that super race car. You know, forgive me for my silly examples, but I usually like to compare data structures and data types as cars, as different types of vehicles. So if you're familiar with the list, and I hope you're familiar with the list, if you're not familiar with the list, please watch one of my previous videos. Like, there is a list, and you could think of a list as a like regular car, all right, that will take you from point A to point B. But what if you need to go faster, like really fast? Then you need some kind of like race car, all right? And that race car is serious, all right? And I'm kind of like running ahead of myself, so let me continue with that story of that guy who was like who actually built pandas. So they decided, since they wanted to go faster, they would need more sophisticated and faster data structures. So they took Numpy, numeric Python, and on top of that, they actually built pandas. All right, so pandas is a library. So the question is, what is a library? So library is a collection of functions. All right, but the main thing actually in pandas is not some kind of like sophisticated or magic function that you learn and you apply to everything and then you like, I know, like king of the world. No, you have to understand that the main advantage of pandas are data structures, built-in data structures. Now, sometimes when I talk to people, especially from boot camps, they say, yeah, I know pandas, you know, you should have seen my project. I've used pandas, you know. And yeah, they use pandas and maybe they know a couple of functions, but they do not understand that core of pandas, all right? And what I'm talking about two primary data structures in pandas. So the first one, and by the way, if you take notes, that would be a good idea. Take notes. So the first one is series, all right? And second one is data frame, all right? So usually when people talk about pandas, they actually mean data frame. And I'm about to explain you what is series and what is data frame, all right? And why I would like you to take notes, because these are usually interview questions. So if at some point of your life you're planning to get a job as a Python developer or maybe junior data scientist, they would definitely ask you that question. Okay, so Panda is kind of cool. What is the series? All right, so let's get started. I hope you got either one, either Collab or Jupyter. I'm going to be using Jupyter here. So first thing first, we need to import pandas. And by the way, let me tell you one more thing. If you decided to go with some other Python environment, so then make sure that you have pandas installed. So if you're not sure how to install pandas, please do not Google it. Just type pip. Pip stands for Python Package Manager. So actually do it like this, like pip install pandas. And of course, you should run this command not in a Jupyter, but in a terminal, in your terminal or command prompt. All right. So pip is Python Package Manager. All right. Now, if you use Anaconda. So pandas kind of comes with Anaconda, and all you have to do is to import pandas as PD. So people ask me all the time, why do we have to import pandas as PD? PD is what, like some kind of magic word, or what's the deal with PD? All right, you could import it as banana. It's up to you. PD is kind of convention. Unless you're trying to confuse everybody around, including yourself, import it as PD, but PD is just a shortcut. It's just a shorthand because people like to lazy to type pandas all the time. So just do PD, all right? Now let me show you a little trick. What you could do PD, period, and click tap on your keyboard here. Tap on your keyboard and you'll see this menu of all pandas functions. Now, based on my experience, this might take a little bit longer if you're using Windows. Why? I don't know. But eventually you'll get there. I'm not sure how long will it take, but some of my students, they actually complain that on Windows it might take a while, all right? But again, how you should do it, you do PD, period, and then click tab key on your keyboard. All right, cool. And then you could see list of all your functions. So now I would like to start with series. And by the way, there is function series. It begins with a capital letter series, PD series. So what is series? So series is a core built-in data structure. If you're not following me and you're asking like, what the heck is data structure? Like, what are you talking about? Now, you should learn data types and data structures, all right? And also, we did a video on that, so please go through my channel. So data structure is kind of container that holds bunch of data, all right? So it could be integers, could be floats, could be strings, bunch of information, right? So series is one-dimensional. Now, if you ever go to job interview and they would ask you that kind of question, hey, what is series? And let's say you don't remember and you have no idea what they're asking you. The easiest way to answer this question would be to use Python function help. If you run help on series, so first of all, it will give us this definition of series. And if you scroll down, you'll see a bunch of examples how to create and use series. So help is a really cool function in Python. All right. So if you have no idea how to use something or you're not sure what you're doing, go to help. It's right here and it's much faster than Googling this stuff. All right. So what it says here, it says one-dimensional and array with axis labels. All right. So what are they trying to tell us here? So and array, it means Numpy array, because remember I told you that to create pandas, so they actually what they did, they took Numpy array as a core and then they actually attached axis labels like index. And in a minute it will be much clearer because I'll show you an example. All right, and also it's one-dimensional. All right, cool. So we already know one-dimensional data structures. If you're using Python, you probably heard of a list. So let's create a list, and let's create a simple a list. And let's say here I got 10, 20, 30, 40, 50. All right, so that's a simple Python list, right? So it's also one-dimensional data structure, Python built-in data structure, right? So then the question, why would we need series in other one-dimensional structure? So let's convert this a list into series. So let's create this variable name as, and do this PD series. So series, PD series is the name of that function. It begins with a capital letter, and by the way, Python is case sensitive if you didn't know. Now, and you could pass here a list. All right. So let me close this help for now. Let me run your cell. And let's see. All right. So here we have this series, you see. So let me explain you something about series. First thing first, what is this on the left? This is index. All right, so this is index 0, 1, 2, 3, 4. Now, somebody a long time ago asked me, hey, like index kind of cool, but can I get rid of that index? The answer is yes, but if you get rid of index, then it would be something else, not a series. All right, just keep that in mind. Now, what is index anyway? So if you ever use sequential databases, you're probably familiar with the primary key. So these guys actually borrowed the same concept from a database, and index kinda works as primary key, all right, for each item. Now, the only thing that you have to keep in mind, and you know that if you worked with SQL, for example, that primary key is always unique. Now, in case of series, you might get duplicates. You don't want to get duplicates, but you might get them. If you, for example, if you concatenate into series, you might get them. All right, just keep that in mind. So that's the main difference between index and primary key. All right, so these are values. Now then we also see this int64 data type. All right, so why are they showing us this stuff? Now this is very important. If you watched my video on list, you probably remember that by nature, list could be heterogeneous. So what it means that in a list, I might have a bunch of integers and then bam, a string, or I might have a string and a float, all right? And that's not a good thing. So to make series, they actually made sure that series would be homogeneous. So there is no way you could actually mix different data types within a series. So let me show you an example. So this is our series. So for example, if I decide to replace this first item from a series, let's say 20 with let's say 200.78. 200.78 is a float. If I run this, you know what's going to happen? It will convert this float to a string, because this is important. Please write it down, because series always homogeneous. That's why it's fast. All right? That's why it's much faster than a list. All right? So now keep that in mind. That's why I'm showing you that all items here are integers. All values here are integers. Now you might ask me, all right, so what if we force it to accept a string? It might take it, but then it might convert everything to strings, or it's always got to stay homogeneous. Just keep that in mind, all right? Cool. So what else? What else that makes series so fast and so, I know, like so cool? Now, for example, if I ask you a question, hey, can we go through this list and take each number and divide each number in that list by 2, for example, right? So you would tell me, hey, we would need to use a for loop. We would need to iterate, grab item by item, number by number, and apply that math operation to each number. Now, when you work with series, you do not need to iterate through a series, because you could apply math operation not to each element one by one, but to whole series. Watch me, all right? So you see what I'm doing? I'm applying this division operation to every, not to every, but to the whole series at the same time. So this is called vectorized operation. How does it work? Oh, it works because under the hood of this series there is NumPy array, and that's kind of behavior built into NumPy array. All right, so that's what we call behavior of different data structures. Okay, now, and because in NumPy you could think of NumPy, one-dimensional NumPy array as a vector. And for example, if you have a, let's say, vector, and you want to add a number, let's say vector plus 2, then you cannot just append that vector with 2, but you need to apply that operation to each value. All right, so you see what's going on here. So now I'm running this vectorized operation. I'm taking this 2, and instead of running the for loop on series, I'm just adding 2 to the whole series, and that's a result. So you see, now the point I'm trying to make is that series is much faster than Python list, and you have to treat it differently. How? For starters, never ever run the for loop on series. Why? Because it makes no sense. Because you got a race car. Why go slower? You gotta treat it differently. All right. So this is an example of vectorized operation. Okay, now you could add series to itself. You see what we're doing here as plus s, and you see what it's doing. It's actually adding all these values. So that's another example of vectorized operation. Now series got 2 major attributes. All right. So the first one is index. And here we see that index comes as a range of values, starting point at 0, then we got stop at 5. How come we don't see 5 here? Because 5 is excluded. It's not included. All right, just keep that in mind. Then second one, values. All right, so guess what? Values is actually NumPy array. You see, this is exactly what I just told you, and that's what I started with. If you take a series and strip it off of index, you're gonna end up with a completely different data structure, NumPy array. So if we take that series and break it down into 2 parts, we're going to end up with the index and values as NumPy array. All right? If we combine these 2, we're going to get series. That is it. That is it. All this behavior of vectorized operations comes from NumPy array. All right? Now, I hope it's fun so far. And by the way, I'm planning to do more live streams on Pandas. So please sign up for this channel, because we're going to be doing pretty regularly like streams like this. I hope every other week. And if you don't want to miss anything, so please join my channel. All right. Now, series is kind of cool. So what's going to happen if we take bunch of series and combine them together? What's going to happen then? Then we're going to get 2-dimensional data structure, data frame. Ta-da! All right, so let's talk about data frame. Again, if you have no idea what data frame is, then you could always do help data frame. Now, data frame function, please be careful here. It begins with a capital D and it's got this capital F. All right, so if you run this help on data frame, what we see here, 2-dimensional. Size mutable means you could add more columns, you could remove columns. Potentially heterogeneous. Oh, why is that? Because I told you that series was homogeneous. Now keep in mind that in one data frame you could have a bunch of series, so each series might hold different values. Just keep that in mind, all right? And I'll show you a couple examples. All right? And data structure contains labeled axes, rows, and columns. All right. So now sometimes people think that if you want to work with a data frame, then you need to grab that Excel file first, then you need to convert it to data frame and work with it. Now, let me show you the simplest and easiest way to create a data frame from scratch. There are a bunch of ways how you could create a data frame, but I hope you'll remember this one. So to initialize a data frame, let's create a variable named df. And you probably know how to initialize a list. You know how to initialize a dictionary. You've done that many times. You got to assign these empty square brackets or curly brackets or something like that, right? So here, to initialize a brand new data frame, what we need to do, we need to use this function, data frame, like this. All right? So what just happened? We have created, initialized an empty data frame. All right. So if you're curious and you want to see what's in there, so let's run it. Pretty much nothing. It is empty. So df empty. It's empty so far. Now we could populate it with data. Now, my old background is finance, so forgive me for my financial examples. But let's create a simple example. Suppose we want to build a portfolio of stocks. All right. So df, suppose that's our portfolio. So df square brackets, and here in square brackets, quotes, we need to come up with some kind of name for our future column. So let's say stock. Now, I don't know if it reminds you of anything. It's actually dictionary annotation. So I hope you're all familiar how to use dictionary in Python. And in Python dictionary, if you want to add a value, you gotta come up with key, and you add a key and you assign a value. So that's pretty much the same stuff here, because guess what? I'm gonna tell you a secret. Do not tell anyone. All right. Now, data frame is a specialization of a dictionary. So that's why you could use pretty much same syntax on a data frame. Surprise, surprise. So if you haven't done that before, you better go back and learn how to use dictionary, because that's like really important and crucial. All right. So df stock, and then suppose we have couple of stocks. So suppose I have IBM, and then I have, I know, Microsoft, and then I have Apple, and let's do one more. I have Intel. All right. So now these are symbols for stocks. Now let's assign prices. All right. So keep in mind, this is legal disclaimer. So what I'm doing here got nothing to do with financial advice, and the numbers I'll be using for stock prices, randomly pick numbers, so please do not use them for actual trading. All right, so that was legal disclaimer. Okay, so now suppose here I'm gonna have price, and then, all right, suppose IBM is 187 and Microsoft 56.97 and Apple 210 and 34, and Intel is 23.67. All right. So again, what I'm doing, I'm trying to populate a data frame that I have initialized on line 15 with a function data frame. So now let's see, what do we have here? Ta-da! All right. So that's a data frame, ladies and gentlemen. All right. So it's two-dimensional, columns and rows, two-dimensional, panel, data. All right, kind of cool. You see, we just created that stuff from scratch. By the way, I usually get this question asked like, looks like Excel. So what are you using Excel here? No, because Python and Pandas more efficient and much faster than Excel or any other spreadsheet. All right, so it got nothing to do with Excel. Can you use Pandas and Excel together? The answer is yes, you can. You can grab an Excel file, you could fetch data, you could manipulate that data with Python, and then you could store that data again as an Excel file. All right, so yeah, you could do kind of stuff like that. All right, but this is the data frame. So let me explain it to you one more time. So here on line 15, I have initialized an empty data frame. And then I populated, I actually created a couple of columns, stock and price, and I assigned values as a list. Now, and by the way, so here we have two columns. And remember, I told you that if you combine a bunch of series, you're going to get a data frame. So that was true. So if you slice that data frame, so let me get rid of this. So if you slice a data frame, first of all, how would you slice a data frame? So data frame is specialization of a dictionary. How would you fetch a value from a dictionary? So you got to grab it by a key. So the same logic works here. So what you got to do? You got to do df price, name of that column, and bam, you're going to fetch that column. All right, so you're going to fetch all these values. df price, so that's a dictionary annotation. And by the way, if you run my favorite function type on this thing, surprise, surprise, it's a series. So the point I'm trying to make that each column is a series. If you combine them together, you're going to build a data frame. If you slice them off, if you slice a column off, so that column would be series, completely different data structure. And again, series is one-dimensional data structure, right? So, and data frame is two-dimensional data structure. So that's the point I'm trying to make. And this is how you slice. This is how you slice a column. Now, let me run my other favorite function dir, and dir is a built-in Python function. Now dir will show you all attributes and methods of an object, and the object we're talking about here is df, data frame. So if I run dir on df, interesting, surprise, surprise, we have price and stock here. So price and stock, although we came up and we created these two names, now they are attributes of our data frame. All right, and it means that since they're attributes, I could get the same result if I do df price. You see? So you could use, all right, so there are two options how you could slice a data frame, how you could grab a column. Now, the first one on line 22, you use dictionary annotation. In square brackets, you should provide a column name. Now, the other one is you grab it as an attribute, because column is an attribute of a data frame. All right, so you see, you could go either way. Now, there is one difference though. If you have a column that contains space, white space, so suppose you have like close price, close space price, then there is no way you could grab it like df.close price. All right, so then you would be forced to use square brackets, and then you would need to use this dictionary annotation. All right, so that's the main difference. Now, if we can slice a column, how would we create a column? How would we create a column? So this is our data frame. And funny story, a long time ago, a friend of mine went to a job interview a long time ago. And he considered himself as a pandas guru. And he was asked a question, how would you add a column to a data frame? And he thought there was some kind of function that he didn't know or didn't remember or something. Apparently not. Apparently to add another column, it's really, really easy. All you have to do is to come up with a column name, let's say position. So what I mean here, a number of each stock in my portfolio. All right, so how many shares do I have in my portfolio? So position, and suppose I don't have that information yet. I don't have that information yet. So then you could actually assign an empty string as a value at the beginning, And now you see we got this empty column. Kind of cool, right? So it's like nothing new. It's pretty simple. It's a dictionary annotation after all right? So please go and review dictionaries, all right? So, but then suppose we got that data. So when you got this data, and now you're ready to provide these values, so you could easily, pretty much like in dictionary, reassign the values. All you have to do, grab that column again, and then suppose I have 100 shares of IBM, so 100 shares of Microsoft, and then what? 100 shares of Apple and 200 shares, 200 shares of Intel, you see? So we easily reassign the values. You see, this is how it works. Pretty easy. Now, again, of course, you got to have proper foundation, and by that I mean, please learn Python built-in data types. That's like cornerstone of any programming language, and you see, like this would pay off, because if you want to work with more sophisticated data structures like data frame and series, it would be beneficial to know and be fluent basic data types and data structures. All right, kind of cool. All right, now keep working on our portfolio. Now I want to get a dollar amount for each position. So for example, I want to know how much my stake in IBM worth. So how would I get that number? Pretty easy. All I have to do to take that number and multiply by number of shares. All right. So how would I do it? Now, first thing first, we need to slice that price. All right, so we need to slice that price column. So that's column price, and we need to multiply it by DF position. You see, so that's a cool example of vectorized operation. Now you see, all I'm doing, I'm multiplying values from one column by values from the other column. All right, now I need to store this result, so I would need to do df square brackets, and then let me call it, let's say, amount. All right, so that's let's suppose that's amount. Now if you take a look, so here we got this column amount. Now you're probably wondering why again I'm doing it like this. Can I do it with square brackets? So yeah, we could actually rewrite the whole thing using dictionary annotation. And again, if you're curious what's the difference between doing it like df period price and df square brackets price, there is no much difference. You're going to get the same result. Now, the only thing that you have to keep in mind that please, when you create a data frame from scratch, do not use spacing between words. All right, so just keep that in mind. Now, sometimes it's hard to do because maybe you're reading this data, from some kind of file, all right, at your company, and they won't let you to rename columns. So now you see we got exactly the same result. So pretty much syntax on line 32 is doing exactly the same thing that you see here on line 34. All right. Okay, so this is how you would work with columns. Now, data frame comparing to series has three major attributes. Now, what are they? So, df index, and it's pretty much like what we've seen when we were working with series. So here we got range index, start, stop, step. Again, stop is excluded. That's why we don't have row 4 in our data frame. Then df columns. All right, columns, and you're going to get all these columns. Now this is like really cool attribute because sometimes and of course right now we're working with a small tiny, I would say, toy data frame, just for this example, uh, we could see all the columns. But what if you fetch huge data set in real life, right? So it might be so big that it won't fit on your screen. So then you want to see all the columns. So then, bam, you're going to get all these columns by doing df columns, all right? So that's like really useful attribute. And the last one, values. And again, we see Numpy array. This time it's two-dimensional. But you see, again, if you take a data frame, if you break it down, you're going to get three pieces: index, columns, and values. And it's all based on Numpy array as a core. All right, so pretty much they took Numpy array, attached index, columns, and bam, you got this super race car, which is data frame. Now, a couple of more things that I want to show you today before we go to Q&A session. So there is really, yeah. So let me show this first. Usually I get this question, yeah, but that's kind of cool. But how would you write this data frame into Excel file? Or how would you read the data frame from Excel file? The answer is simple. If you watch my previous videos, you know that I'm a fan of function dir. And if I pass here df, then I'm going to see all these methods immediately. So if what you want to do, if you want to take this data frame and store it as an Excel file or CSV file or maybe in some other format, then before Googling, please use Python built-in function dir. And if you scroll down, you see there are a bunch of methods here. Then you'll find these methods. So you see there is method to Excel. So all you would have to do, df period to Excel and pass that desired file name that you want to save it under. All right, or if you want to save it as CSV file, then to CSV. So if you're not sure what I'm talking about, then again help comes into play. So if you're not sure how to use this method, then you could do help and run this, and they'll show you a bunch of examples. You see there is no need to Google anything. So they're saying, all right, so this is Excel. So here you need to come up with some kind of name, all right? And they even provide you with a bunch of examples here. So they create this data frame from scratch, and then they will show you how to use this, how to save this data frame as an Excel file. All right. So now I hope this was helpful. Now one last thing that I want to show you, my favorite method, info. All right, info. So I usually use info when I work with a new data set. Suppose I'm getting that data coming from API, or maybe I'm reading some Excel file, and maybe I see the data set for the first time, so I have no idea what's going on there. So the first thing I would do, I would take this method info and I would apply it to data frame. And let's see what we got here. So here, it shows us that this is a data frame. All right, we kind of knew that already. So then it shows us that we got 4 rows. All right, and then it shows that this data frame got 4 columns. All right, cool. Now the most important part that I'm usually looking for is data type of values in each column. So this is very important because sometimes you grab data from API and you're thinking, all right, now I'm going to analyze that data, and apparently you cannot do anything because you got a bunch of strings. Because if data comes from API, so most of the time it would be coming in form of JSON, and JSON just a string, and JSON stands for JavaScript Object Notation. So the point I'm trying to make, before you start like manipulating your data, before you start doing some vectorized operations or some data analysis, just run this info, so then you could see, oh, okay, so price float, these integers and these are floats. That's kind of cool, but these are numeric data types because we have created that data frame from scratch. All right, but sometimes there could be something else like object. Object most of the time means string. All right, so string, so they here instead of a string they would say object. Just keep that in mind. All right, so bottom line, Pandas is really powerful library for data analysis, and the most important part about Pandas that it comes with series and data frame. So series is one-dimensional data structure and data frame is two-dimensional data structure. Now, why is that so important? Because they're ridiculously fast and efficient, especially if you want to manipulate data. Now, so we just scratched that surface a bit, and my goal here is to do more streams like this, live streams where you could actually ask questions, and we're going to get to questions in a minute. But if you want to learn more about Pandas, if you're curious how you could grab rows, how you could filter, or how you could do logical operations on data frame, because it's not about just filtering. We want to filter, of course, but we also want to do something. So for example, if something, do something else, do something else. So if you want to do, like, if you want to apply some logic, so please let me know in the description to this video. And I'm planning to do more streams, so please join this channel. All right, and right now we have chat here, so please let me know if you have any questions, if you have any questions about anything that we have covered so far. Okay, I see that we have people from different places. All right, Chicago. Yeah, great city. I miss Chicago. All right, any questions? Any questions? All right, so if you have no questions now, you know where to find me. You could, first of all, you could follow me on Twitter, and you can find me there. And also, you could post your questions under this video. Can you explain again why the S okay, so Susan asking about index one more time. Okay, so let me explain it to you. So here index comes as range. All right, so that's kind of like roots going to that function range. If you know, Python comes with a built-in function range. So it's one of the built-in functions. It generates range of numbers. If you run help on range, so oops, help on range, so then it will tell us that range requires at least one argument to generate that range of numbers, stop, and then there is start, stop, step. Now the thing is that historically stop is exclusive. It's exclusive. It's not included. All right, so in this case, when we get range of this data frame as a range index, that's pretty much same logic. So it shows us that you got 4 rows, 1, 2, 3, 4. In programming, we always start counting at 0. So it's saying start is 0 and stop is 4, but stop is exclusive. So that's kinda like you could find this parallel with function range, all right? And also when you do slicing, in Python, stop index, stop point is also not included. All right, so non-pi or non-pi. I'm sorry, I didn't get it. William, I'm not sure what you're trying to say. Non-Python or non-pi. Okay, I'm not sure. Will you be doing a later session on working with some data sets? Yeah, sure. So if you like it, we're gonna grab some live data, some real live data from, let's say, some kind of website on API, and read it as a data frame and analyze it a bit. All right? Yeah, sure, we'll do that. So if you don't want to miss our streams, please follow me on this channel. So asking about Numpy. So what about Numpy? So like I said, Pandas is built on Numpy, and Numpy short for numeric Python. So that's a core library. And by the way, if you're using Jupyter, here if you go to help, you'll see all these core libraries here. So there is Numpy, there is Pandas, Matplotlib, library for data visualization, SciPy for scientific Python. So if you click here, it will take you directly to Numpy, and then you could read about array, and that's pretty much what we were talking about. So they actually took this data structure, attached that index, and bam, now you got series. Okay. Short for numeric Python, right? Small classification when we type df to Excel as an Excel sheet created or it's added to an existing file. No. So Simon, when you do to Excel, it will create an Excel file from scratch, unless you want to append it. All right? Because again, if you go here and if you run this help on df to Excel, so let's see. So the same so it will create a brand new file for you. Then you could actually specify if, like, maybe in your file you got a bunch of sheets, so you could do you could specify what sheet should your information be on. All right, and it will create a brand new Excel file. Let me see. I do not remember if you can append that file. I think so. Yeah. You definitely. So, for example, if your goal is maybe you gather information on a regular basis, and maybe you already got a file where you're keeping all your information, and if you want to append that information constantly, so then yes, you could actually. There is a way how you could actually append that information to existing file. Otherwise, it will create you a brand new file. Okay. All right, guys. So we're all done for today. So please join my channel, and we'll do more pandas in a week, and then I'll see you there. All right. So thank you and goodbye.